Okay, well, first off, thanks everybody for coming. Thanks to Briebug for having me. So my name's Dan Wahlin. As mentioned, I live in Arizona, so it was a nice short flight over, and we are here for about the next hour or so to throw in pretty much every technology I could think of in one talk. But we're going to talk mostly about how we could use something like microservices. How many are using microservices right now? Anybody? Okay. How many are going like the full-on separation of database and everything microservices in here? Okay, quite a few of you. So we'll talk about some of that to get started. Really the goal of this talk though is, Angular's great, but when it comes to real life, your ng serve command is probably not going to cut it for production. So we're going to talk a little bit about containers. We're going to talk about how that fits in with this concept called microservices a little bit. The backend doesn't really matter. The demo I'm going to show has a Node.js and ASP.NET Core backend, but it could literally be, Ruby, it could be PHP, it doesn't really matter. So you can get to the slides for this through this URL right here. It is a case-sensitive URL because I use bit.ly, so just as a heads up, if you want to mess around with this at all, there's going to be a lot of GitHub repo links that you won't want to type. So if you just write down or take a picture of this one link, that'll get you to everything for the rest of the talk. All right, so I'll give you another couple seconds here, and then 5, 4, 3, 2, 1, we're going to move on. All right, so for those that don't know me at all, I've worked with a lot of technologies over the years, but obviously I'm a big fan of Angular, and got started like a lot of you with well, I don't even know what it was. It might not have been 1.0 at the time, but early Angular JS. Once I got into that, then obviously Angular 2 came out. I've been a big fan of TypeScript for many years, and so when they moved to TypeScript, I was kind of cheering that move. But we're not going to talk so much about that aspect today as how can Angular fit in to a kind of microservices type of architecture. And for those that are already doing some of it, you probably know some of this, but for those that haven't, hopefully, by the time you leave tonight, you'll have a pretty good idea about how things like containers and other things can fit into this Angular ecosystem, we could say. All right, so let's dive on in. So most of us have built an app like this, which we would call a monolithic application. And this is where you have your different layers. You architected it. But to actually move these layers, oftentimes you end up moving the entire app because there's a lot of dependencies between these different layers. Now, this would be anything as far as technology. It isn't necessarily Angular per se, but the challenge with this monolithic is there's a particular company out in Florida that we work a lot with. It's a supermarket chain. And they have this challenge that when a new hire comes on, kind of going back to what Chuck was talking about, they cannot be productive right away. It's like you got to have a PhD in the application project structure just to even know how to build the dang thing, right? So the other problem they had, or have still, because they're still working through this, is now when they go to production, they're a .NET shop in this case, but it could be Java or whatever. They have a ton of dependencies they have to ship. So it's not just like they can ship one part. The way it is now, it's kind of a 3-day march. And at the end of the 3 days, you hope it works. They do have automation, but still, when you're deploying that much just for one small fix, you tend to have problems. So if anyone's worked with this before, it's not that it's evil, but it can be. Especially when your app just keeps growing and growing and growing. And it really tends to lock you into a given technology. And we all know that just since I've been talking, what we thought was cool is no longer cool because everything changes about every 5 minutes. Now, from a microservices standpoint, this is kind of what we're going to talk about mostly tonight. This is where we think much more granular. So you might have a customers feature, an orders feature, lookup tables, those types of things, and oftentimes those might be separate projects or something, but it ends up being monolithic and kind of one big just monstrosity. With microservices, let's say you're doing mobile and web and maybe even desktop apps that need to get this data. Well, we can actually go in and break out our different parts of our system into these microservices. Now, I'm going to talk about pros and cons because this is one of those big buzzwords. Does anybody have a CIO or director who's been to a conference recently? They heard a buzzword, and next thing you know, you're doing it. And of course, they don't even know what it is that they're doing, but they heard it was cool. I think microservices is in that realm right now. It can be very good, but if you don't know what you're doing and don't plan it, it can also be very evil. Has anybody been around long enough to remember the whole SOA? Some of you probably still have this, all right? Service-oriented architecture, that was the answer, right? And apparently not. Corba, I don't know if anyone remembers, that goes way back in the day. That was the answer, and well, apparently not. So microservices have a lot of pros and cons. I would argue the pros certainly outweigh the cons, but it's good to know about these. So we're going to talk through that really quick. Then we're going to jump into how containers could actually be used to, well, containerize, to make it so that we can consistently deploy between different environments. So as Chuck mentioned, if you don't have a good automation for that, it can be very painful, but even with automation, how many have deployed and everything's working great on, staging, and then you go ahead and, all right, we're going to production, and it turns out there was, I don't know, different security, different environment variables, different patch on the server, who knows? There's like a huge number of things that could come up, and I think we've all probably been through this before. So with microservices, the idea, if you're new to this, is that we can break our app up into these kind of self-contained bubbles. And the idea is that way, if I want to use, say, Node.js right here for my basket for shopping cart, I could. If I wanted to use ASP.NET Core, I could. If I wanted to use something else, I could. Now, I'm not saying I recommend that necessarily, because I think if you get too many texts going, people do leave jobs, and somebody's got to maintain it. But you do have that possibility, and it makes it easier in the future that if I want to swap out technologies for a given microservice, then I could. And that's actually pretty compelling, because those that have been in the business a long time know that once you kind of get into a framework pretty deep, it's not like you could just switch off to another framework the next day. All right, we're talking probably months or more of work in some cases. So the idea here, and a good example of this is Wunderlist. I don't know if anyone's heard of them. Microsoft recently bought them. But they, I guess, have hundreds of microservices, and back before they were Microsoft, I guess their CIO, I saw a talk he gave, pretty much said, I don't care what you use on these different features. I literally don't care. As long as your service works, we're good to go. Now, like I said, there's pros and cons to that. We'll talk through some of that. When it comes to Angular, whether you're using it in mobile or just as a kind of a standalone SPA traditional type of app, both of these can call in. Oftentimes you'll have what's called a gateway that'll do the routing to these different microservices. And then you might also have just a traditional web app that also needs to call into these different microservices. So the concept, if you're new to this, isn't really a new concept. This kind of looks like what we used to. In fact, I gave lots of talks in the early 2000s on service-oriented architecture, right? And microservices, in my mind anyway, this is where it gets very debatable, but microservices really are all about the same concepts. We want to isolate, we want to be able to swap and update services very quickly without having to redeploy the entire app. But it's kind of like the next iteration of what used to be called SOA, plus we don't really use SOAP in this world. We could, but most people don't. So the idea here would be a car if they welded on the wipers, as an example. Like literally to get your wipers replaced, you have to get out the welding piece and fire up the gas and cut that sucker off, right? That'd be bad. Luckily, we don't have that. Now, I would argue today's cars are a heck of a lot harder to maintain than what we used to have. But the idea is that we can replace individual parts of that car. and the brakes are kind of independent from everything. The tires, the wiper blades, the whatever else you have in the car. And that's kind of the idea with microservices. Now, when it comes to using these, let's talk through just really quick here, kind of pros and cons, and then we'll jump into some Docker type stuff with Angular and other techs. One of the nice things about microservices is you really can take what was a really super kind of big, hard to follow thing, and you can convert it into a much smaller, small team could work on it even, much easier to deploy, and that's kind of the general idea, is that you start defining some boundaries on features, and then you start breaking those up into these microservices that we want to have. Now, what's nice about these, and this is where this company, and a lot of you have probably heard of them if you've lived in the Southeast, they really want this. They want to independently deploy some of these service features, because right now they can't do that. Not with all their apps, but with one particular app I know of, it's a pretty involved process from what I've heard. And while they have super sharp people there, like they have some really good developers, the process has, over the years, got kind of big. And I suspect, well, I know they're not alone, because I've built these apps. I suspect in here, you've built these apps. How many, as of today, still have these apps? I mean, a lot of us, right? It's pretty common. So that's one nice feature, though. Also, independently scalable. If you do a monolithic application, then that monolithic app is kind of one big piece that you got to deploy. You might be able to deploy a jar or a DLL and call it a day, but oftentimes there's a lot of tightly coupled dependencies. So one of the nice things here is that we can actually independently scale these services. So if, for instance, the customer order service was taking all the hit, and we're really seeing some high traffic loads, then we can scale out that one independent thing. Whereas, if we had the monolith app, it's kind of hard to do that. You're scaling out the whole app, right, if things aren't broken out. All right, now also when it comes into hardware, or if you want to use containers or not, you may not use containers, and that's okay. We're going to talk about that. I use containers for everything. But now you can very easily switch your different services to different hardware, which is pretty cool. Small development teams. One of the challenges a lot of the companies we work with have are, only a handful of people know this one feature, and if they ever leave the company, they're in big trouble. Whereas with a microservice, now you can have just a really small part of it. You don't want to go, I don't know, I've actually heard of microservices where people are like, yeah, let's take a function, and every function we have, we're going to make that an individual service, and I'm like, how about not? That might be an overkill. But I mean, you could. That's kind of what's cool here. And you hear about the new architecture on Azure and AWS, where you have the serverless functions and things, and there's some value in that. But we can really divide up the team, so maybe they just work on one microservice, or maybe a handful of them, but they don't have to know the whole app. Now when a new hire comes in, they can jump right into a smaller part of the app that does one thing well, and then work with that. So you get some benefits there. Fault isolation, this is also very good. Oftentimes with a monolith, if it crashes, kind of the whole app goes down potentially. It just kind of depends on how you architect it, but that's another nice feature. This might be one of my favorite features right here, no long-term stack commitment. Now, I don't think we go into work on a given day going, I think I'm going to rewrite everything to this. Although on a given day, you might have a manager like that, where they just like to switch technologies all the time on you. Well, with this, though, we would have that flexibility to swap this out if we wanted to a different technology and not have to rewrite the whole app. And that's actually pretty cool. And then, of course, it's very modular. Now we're literally thinking in terms of these smaller services that we have. Now, that's some of the rosy stuff, but it's not all roses. This, for those that have done some microservices, I suspect you will have hit some of this that we're going to talk about here. So the first thing you'll hit if you have a monolithic app and you want to break it down is knowing where to draw the lines. Because oftentimes a given service needs another service, and they almost seem like they're the same thing, but you want to break them apart. So that part gets a little trickier, but that's where you have to just sit down and iron it out in some meetings with agendas. I am a big fan of agendas. I do not go to many meetings unless there's agenda. But anyway, the other challenge here is if you do distribute this without much planning, and we'll talk a little bit about that towards the end, you could just have made an even bigger monster. Because what ends up happening with microservices, you now have more network calls typically. And if you're not monitoring all the different services that are up, and that's why I like containers, which we'll get to, then that can be a little more challenging than maybe it should be. Also, it does add complexity for the distributed system because it is a much more distributed system now. Now, from an Angular developer standpoint, you're used to making RESTful APIs or GraphQL or whatever you do. So for us, that's what we do, right? But now we're talking about every little thing, even lookup tables for dropdowns could be a microservice, which is a separate call. And now you need to plan for that, of course, because now new timing issues come up on when the data comes back, and on and on and on. Now, luckily, because Angular has RxJS and observables and all that, it's pretty easy to mitigate that. But on the back end, a microservice might call another microservice. So it's not just as simple as just the Angular point of view that we have. The complexity of managing the microservices that are up. Again, how do you monitor those? How do you know when one goes down? If one does go down, how do you scale it or bring it back up and heal it? And the good news is there's a lot of systems out there that will do that. Kubernetes, as an example, for containers can be helpful there. This is another kind of hard one. When you have features that span across multiple services, and this kind of gets back to the top one I mentioned on decomposing. That gets a little bit tricky, but that again is just architecture and reading up on some of the patterns that are out there. When to use a microservice? Is it appropriate for every app? I don't think any technology is appropriate for every app. I think people that say that have not done much. There's no such thing as you don't walk into the shoe store and go, give me a pair of shoes. And they go, well, what size? Oh, it doesn't matter. Just give me a pair of shoes. I just need shoes. It's like, no, one size does not fit all. And so that I would argue that applies to microservices as well. I think there's some great use cases, and there's probably some where it might be way over complex over what you could have done. Now, this is probably one of the biggest ones you run into. With microservices, a couple things end up happening. So let's say that you built an ASP.NET Core microservice that Angular hits. And then you also, another team decided to use, say, Node.js that Angular hits. And now you, as an Angular developer, have to hit those. Well, that's no big deal. But what happens when one of those services has to call another service, and maybe another, and maybe another? And what happens when there's transactions involved between all these services? This is where microservices get a little tricky, and while we're not going to have time to go into that aspect tonight, if you're new to this and you have been looking at microservices, that's one of the very first things I personally would look at, is how are we going to manage transactions across services? And there's some patterns. You can do this. There's the Saga and orchestration and stuff like that patterns, but it does take some planning. So again, it's not all roses there. Now, here's the last thing to point out, and then we'll start looking at some containers with Angular and stuff. Normally with microservices, every microservice has its own database. And the reason for that is we want to independently deploy these services. So if multiple services use the same database, it's a little bit harder to migrate a given service because we might have to change the database. Then that might affect other services. So if you're going I'm 100% in on microservices, then traditionally what will happen is your microservice will have its own database. Now that sounds great on the surface, but how many do reporting at all in here? And how many sort of depend on the reports coming from tables that are sort of in the same area, right? It's pretty normal. So that's one of those other things you have to plan for, is now you literally might have more database servers going if you're doing the full microservices. Now, again, there's different levels of this. You don't necessarily have to do that. And I know a lot of companies that they'll just break the code out, but they'll leave the same kind of big database. All right. Now, I'd argue that's not a maybe 100% accurate microservice, but it's starting to go down that road at least. So I still think there's some benefits there. But just kind of want to make you aware, if you're new to this, that is something you have to plan for as well, is kind of the database concept. All right, now having shown a couple pros and cons there then, let's kind of talk about, before you move, like what questions would you ask? And number one thing is, are multiple teams working on different business areas of the app, or is it just one team? All right, how do you want to divide that up as far as the teams go? All right, is it hard for new team members to understand your app? How many have an app that if I was to walk in right now, you'd go, yeah, it's going to take a while to figure this out? Yeah, and you know, I mean, how many work on an app where you feel like that on a given day? Yeah, where you're like, yeah, it's going to take a while, and I've been here 2 years. I mean, it's pretty normal, right? Apps get big, and as they grow, the complexity grows. But again, that's where microservices might help out. Does your app have rules or something that changes frequently? Okay, if it does, then microservices that's kind of what they're good at. You know, you can swap out the technology, you can independently deploy that microservice, and that makes it a lot easier when it comes to the deployment aspect. What about subsystems here, right? Are you able to change any of the subsystems of your app without like breaking the whole, house of cards falls down? And for a lot of you, I bet you're like, nah, ours is pretty much a house of cards. If you blow wrong, it blows down, even with automation. So that's kind of one of the promises of microservices, is that we can isolate this a little better and minimize that type of impact. Then the last one here, if you were required to switch technologies, how easy would it be? And I think for a lot of us, not easy, right? Like it'd be a massive rewrite. Well, again, that's where with microservices, you could just replace an individual service and slowly start to do that over time without having to rewrite the whole app. And that's kind of the general idea. All right, so where does Angular and Docker and all this other stuff fit in then with microservices? Well, for now that we've covered just a high-level kind of 10,000-foot view of microservices, let's talk about how we could actually use containers to help with this. Now, first off, real quick show of hands. How many are you already using containers in here? Okay, quite a few of you. A lot of you didn't raise your hand, but quite a few of you. So I'm seeing definitely massive adoption nowadays. Docker just turned 5, and while there's other container options out there, Docker's by far the most popular, at least as of today. So let's say I had this scenario where I want to host my Angular code on Nginx. That's my preference. If you're not familiar with Nginx, it's a reverse proxy that's very, very fast, and it normally sits on port 80. So it's kind of your first server that gets hit. Typically, you'll put your static files there, like your Angular dist, your distribution folder, stuff like that. Now, let's say that your Angular app then calls out from this Nginx on port 80 to some what we call upstream nodes. Again, these could be any technology. These could be Core. They could be Node.js. Doesn't matter. And then let's say that there's, of course, database interaction. We also have some caching going on. Things like that. How do we deal with all that? So for a lot of us, getting that from point A to B to C is pretty challenging. So if you right now don't have a lot of automation going, this can be extremely challenging. Even if you have automation going, I would argue this can still be challenging. And the reason, again, is that oftentimes in different environments, we just have different setups sometimes. It wasn't, it was an accident. It somehow happened, a service pack got installed, or some other security settings, for instance, were a little bit different. I'm sure you've all hit this. That's another thing. How many wastes on a given day do you feel like you waste more time on security than you do on actually writing code? And those are those not fun days, right? But we all go through it. So where microservices and Docker and Angular and all that fits in here is, while we'll focus kind of on Angular, maybe calling some of these microservices behind the scenes, what I'm going to focus on for kind of the rest of the talk here is how can we containerize this and make it so that we could pretty easily make sure that the exact servers, even down to the server, the security on it, the service packs or patches or whatever, are exact across all environments. Right? That can be pretty challenging. So about 3 years ago, about 4 years ago, I started looking into Docker because I had my blog, which I still use. I'm not a PHP guy, but I still use WordPress for my blog engine just because I got into it years ago and never switched. But the challenge was always getting your WordPress to be exactly the same as production. And we host all our company stuff up on Azure. We have some VMs up there we use. And what was happening was, we for instance, do something very innocent, simple, which is like install a new WordPress plugin. And all of a sudden, next thing you know, the whole server could go down. And if your one server was your production server, which is always a bad idea, you go into freak out mode because it's not working. It's like, oh my gosh, what do we do? And quite honestly, our deployment process sort of felt like this little boat. You put your code in and you ship it across the river or lake, and you hope it doesn't sink, before it gets to the other side for staging and production and things. This is what Docker brings to the table. Docker will allow us to put every single thing an app needs, and when I say app, I mean the Angular side, the microservices, the databases. Even if you wanted, you can even containerize databases. And it organizes them into these containers. Now, if you're new to this, what's cool about it is that, number one, I can get it going very quickly on my Windows, my Mac, or my Linux machines. And if I want to get it going on your machine, this demo I have, anybody in here that has Docker for Windows or Docker for Mac or Linux installed, you could probably get this demo going with all these servers I'm going to have in, I'd say, under 5 minutes. And it would just work. And that's kind of the promise of containerization. So this hopefully looks a little more attractive than this as far as this deployment process we might have for our Angular apps. All right, so if you're new to Docker, just a real quick run through here. This really is all about simplifying running your apps first off in development, but then also shipping those apps between your different environments or even up to the cloud, and in a way that's very easy and very fast, and it just works. I mentioned we host everything in Azure. Well, I can get this exact app. I'm going to show you just a little simple demo Angular app here that uses, how many containers I have? 1, 2, 3, 4, 5, 6 or 7 containers for the app. So basically 6 or 7 servers is what's being used. And I can get that going up in Azure, I don't know, give me maybe 10 minutes, or AWS, or whatever you want. Google Cloud, doesn't matter. And that's kind of the promise of this. It's actually very, very cool if you haven't done it for real. So it's a shipping container system, but it's actually a lot more than that from a dev standpoint. And we'll talk about that. It originally came from Linux, but now it runs on Windows, has native container support if you have Windows 10 Pro or Windows Server 2016. But like all our stuff, we run on Linux servers. Even though anyone that knows me knows that I was definitely a Microsoft guy for years and years and years. And I still love a lot of their stuff, but I kind of like Linux for production, I admit. And that's what we use. All right, so I've already mentioned this, and we're going to talk now about how it works. So the way this works is you'll ultimately create or use something called an image. So for example, if I want to get Angular going for real, not ng-serve, but a real server, a lot of people will use Node.js for that, and that's valid, you can. Or they'll put it on Apache or something like that, but that's like a really heavy-handed approach. Servers like Nginx, HAProxy, and others are designed to serve up static files very, very fast. A lot of CDN code could be hosted on those, for instance. So what we end up doing is there is what we call image out there for Nginx. There's an image for the latest version of Node, for ASP.NET Core, for you name it, there's an image. An image is a layered file system. Now, some of the images are Windows only. Some of the engines, well, most of them, images are for Nginx, actually. All right, so the way this works is you can almost think of this as like the blueprint, your class, if you write and use classes like in your Angular apps. And then we new up the class at runtime, and that creates this thing called a container. Okay, really the only difference between these two is the container adds a little icing on top of the cake, and that icing is called a readable, writable layer. This will be on the final quiz that'll be at the end, so make sure you guys are listening. I want everybody to go home tonight. No. Wasn't that the rule? Everybody had to stay until they pass, right? That's something right. Like that. Till your code compiles, nobody leaves. No. All right, so anyway, the really cool thing about this is the Docker image is not a virtual machine image. This is a layered file system that I can get an image, set it on top of the OS, whatever that is, and it's almost like it merges it together. And so Nginx, for example, if I get Nginx Alpine, which is a really small Linux one, it's like 15, 18 meg maybe total. So we're not talking VMs here if you're new to this. They actually can sit on top of VMs, but you're not creating a new version of the operating system. You're not duplicating the memory, duplicating the hard drives, none of that. It actually sits on top of the VM. All right, so an image is a read-only template that has everything you need to run that server. So Nginx, Node.js, ASP.NET Core, PHP, doesn't matter. You name it. The container would be at runtime it isolates. It's almost like it puts a little force field around it. And what the container ends up being is the runtime version of that server. So again, I like to think of the image as almost like the class. And then the container is like newing up the class. It's like the runtime object, the runtime instance that you might have. All right, let's do a little demo here real fast. So probably the easiest thing you could do with Docker is, well, first off, let me go into one thing. So when it comes to using Docker, we're going to test the Wi-Fi, because I always love to do that. So you'll go out to docker.com and you'll have to install something called Docker Community Edition. Then they also have an Enterprise edition as well. Now I won't do that because I already have things running here. But you'll notice for mine, if I kind of zoom in here a little bit, I have this whale here, and this is my Docker that's currently running. Okay, so I'm all kind of ready to go, but you could also run this on Windows, as I mentioned, if you wanted. Now, the next thing to know is that I mentioned there's these things called images. Well, you can make your own images, but making an image from scratch is a little more involved than finding an existing image and then adding what you want on top of it, almost like class inheritance. Get a base class and then extend it. All right, well, we can do that same kind of concept with Docker. So if I go to hub.docker.com, this is where these images can be stored. Now, Azure has Azure Container Registry, and AWS has one, and Google Cloud has one, but this is kind of the de facto one. And if I go to the search here and just search for Nginx, all right, here's the official image. And then you can read up on it. Now, I'm not going to really do that, but I want to show you that they show some commands you can run, these Docker commands. So I won't have time to go into all the Docker commands. Unfortunately, we just don't have that long. But if I wanted to get Nginx running on my machine, and I do have it because I never trust the Wi-Fi when I go give talks, but if I didn't have it, it would go pull it. And I could do this. I could say, hey, Docker, I want to run. And let me zoom that just a little bit for the back row. There. All right, so hey, Docker, I want to run. And then there's a couple things you need to give it. I can give it a port and say, all right, externally, like if I want to hit this through the browser, what do I call port-wise? Well, let's say 8080 as an example. All right, and then Nginx is inside of this container it's going to download it and then start it up locally. What container or what port does it run on? It runs on port 80 internally. Now, if I wanted this to be 80 and then forward external to internal, I could do that. The app I'm going to show you does that. But for now, let's just do 8080 so I can show you the difference here. And then there's a couple other settings. We can run it in detached mode. That'll make it where if I hit enter, that my console comes back and it doesn't lock it up. I'm going to leave it in not detached mode, in, I guess, attached mode. And then we put the name of the image. So I could say Nginx Alpine. All right, that would be the name of the image that's up on there on Docker Hub. Now, this is what I use for my Angular apps because it's very fast. All right, so if we do this, hey Docker, run on port 8080 external, port 80 internal, and then what's the image? Now, there's a whole bunch more we could give it as far as command line, but let's just go ahead and do that. Now, notice it kind of locked it up, though. That's because I didn't run in detached mode, okay? So if we come now, and let's just run over to localhost or localhost, if I can type it right, 8080, come on, you can do it. All right, there we go. Now I have Nginx up and running on my machine that fast, which is super cool. Now, there's a lot more to the story because there's an Nginx config and there's other stuff you do, but that's how quick it would be to get Nginx up and running. And I could do the same thing with WordPress, with any blog engine you can think of. As long as I know the commands to run, I can get that up and running probably in 60 seconds or less. Depends on the network speed to download the image. All right, so let's go back. Now that you've seen that, you see it wrote some logs here. So let me cancel out of here. And I'm going to say docker ps-a. Now you'll notice it now lists. The ps command is a way to list all of the running containers. The -a is run all or show all, running or not running. And then notice Nginx was created 58 seconds ago, but it exited, well, for now probably 20 seconds ago. Okay, now there's an ID here, AD55, blah, blah, blah. I can now remove the container when I'm done with it. I can say docker remove, and I can just give it AD. That's enough since I only have one. All right, it's gone. So docker ps-a, no containers. All right, that's pretty cool. And then if I go to Docker images, now I have a bunch of images, but if I go up top here, there's my Nginx Alpine. It looks like it's 18 meg right there. All right, now, this one is using the latest version, but another cool thing with this is, let's say that you have Angular version 1 of your app, Angular version 2, Angular version 3, all those. Well, when you make your images, and I'm going to show you the basics of that coming up here, when you do that, you can actually define what's called a tag. You can tag the image so that when you run that container, it's for a specific version of the app. Well, here's another cool feature of these containers. How many have had a problem where you install the framework, whatever that is, on your server, and then you now want to deploy a new version of the app, but it uses a newer version of the framework. But you're scared to update the version of the framework on the server because it might break the older apps. All right, this is pretty common. Well, with containers, I can tag each of my images, and then we'll have unique containers. I could run version 1 of the framework, version 2 of the framework, version 8 of the framework on the same exact server at the same time, and they won't even conflict with each other. That's some of the beauties of containers that I don't have time to go into, but I want to throw that out there. So normally what you'll do is, Chuck mentioned, sometimes when you go to production, you mentioned the 10 o'clock deployment, call the wife at 6. Sorry, I'll see you at lunch, because you couldn't roll back. Well, with containers, those containers are always around, or the image, and so I can always roll back if I want to, which is cool. So there's a lot of cool stuff we could talk about there, but alas, I don't have time to go into all that. So let me go full screen here. All right, let me zoom out. So let's go back to here, and let me just talk through this a little bit more. So steps to do this, number one, you're going to have Docker CE. If you're going to build a custom image, I'll show you the basics of this in a moment for like Angular as an example. You're going to have a custom Docker file. It'd be great if I could just pull down the Nginx or the Node image and say, okay, here's my code, just make it happen. It's not quite that simple. You'll have to make a custom Docker file to build an image, it's called. And then you run the commands to actually fire up the containers and do your work. So the way this works on Mac, uses something called HyperKit and has a really small Alpine Linux VM that runs. On Windows, you'll have Hyper-V, and that's why you have to have Windows 10 Pro or higher. If you have Windows 8 or Windows 7, you still can do it, but you'll end up using something called Docker Toolbox, and that uses VirtualBox as the VM. So it's a little heavier-handed approach, but it works. That's what I used for the early years when I got into this. All right, so let's look at Docker files real quick. Let's say that you wanted to first off containerize your Angular app so that you could deploy it anywhere pretty easily, actually. Now, I want to emphasize here because I had one guy recently on one of my Pluralsight courses. He goes, he basically said, why do I need containers? All we do is we pull the code down to the server and then we deploy the code and we're done. And I said, if it's that simple, keep with it. I'm all for simplicity. But if you want everything your Angular app needs on that or in that container, that's where these custom Docker files come into play. In other words, I don't just want my code, I want to determine what server it runs on down to the exact version of the patch for security like. I want environment variables on there for whatever reason. I have certain security settings I want on there. Everything can be configured to be shipped in the container. Think about when they ship overseas from China to the US, for example. All the products we end up buying. It's not like they're going to put two parts of the stereo over in this thing and another part in this thing. I mean, maybe they do, but I would hope not. The container should have everything needed. Then they drop that on the train, get it to the outlets, and people sell it. And that's really what we're talking about here. So the way this works is for like Angular, you end up building a Docker image. I'll show you an example of that in just a moment. And the way it works is the image is constructed by using this thing called a Docker file. So just like to write an Angular component, you have to have your class and your decorator and all that on top. Well, this is kind of the same premise. It's just we're not writing Angular apps. We're writing these images. So what we do is we run this Docker file, which is just a text file, you'll see, through a Docker build command. That ultimately builds the image. Now, when I'm ready to go to production, we have a new product thing we're going to hopefully release here pretty shortly. When I'm ready to deploy that to production, I simply need to push my image up to my repository. Now, that could be Docker Hub. That could be Azure Container Registry. It could be AWS's registry. It doesn't matter. You need to just pick one. But once that image is available, now I need to just start up the containers. Now that, I will admit, is a bigger topic. You could just SH in to your virtual machine and run some Docker commands if you wanted. Not a great approach, but you could. For those of you they're going to have a lot of containers and a lot of management duties. I would recommend Kubernetes is definitely the way we're going. And so anybody using Kubernetes already in here? Okay, a few of you. I won't say it's a perfect solution, but it's really designed for managing all these images and, well, running the containers. And it can do things like if a container crashes, bring up a new one, or heal it. And there's a lot to it. It's a big product, but it's super powerful and it's open source. It's from Google, by the way. Now, if you're doing ASP.NET Core, they have some images for building those like microservices. So maybe Angular is hitting ASP.NET Core, which is the newer .NET framework that's cross-platform. And they have two main images there that are up on Docker Hub. They have a build, and this would be used to actually build your code. All right, so I could now automate the build process like Chuck was talking about earlier by actually having a container come up on like my build server, and then it does the build. And then we could take the output of that one and pass it to another container that's actually the runtime container. So you can actually kind of chain these containers together, and then when I'm done, I just delete the container. Done. In fact, it's as if it never existed when I'm done, which is super cool. Then they have a runtime image as well, and I won't have time to go into all this, but that's the one you would use like in production if you're using ASP.NET Core as an example. They also have Windows images. If you see the word nano server on the image, then that would be for those of you that run like Windows Server 2016 as an example. Then you could run this on that server, or even on Windows 10 Pro, you could run this because they have native container support. Now, here's kind of what it looks like. A Docker file looks like this, and I'll show you an Angular one as well for Nginx that I like to use for at least development purposes. So first off, you'll say, all right, what is my base image? It's kind of like in a class saying, what's my base class that I'm inheriting from? They don't have decorators here, so you do this. All right, then you put a maintainer, or you might even see, I need to update that actually. There's another way you can do it now called a label as well. This still works too though. All right, and then you're going to copy in the code that you actually want to run into the image. It creates this file system, layered file system. I like to think of it like a chocolate cake, and every instruction that you see adds a new layer to the cake. Okay, and that's kind of what we're building here is a cake. So this is going to copy my local folder, that's the dot, into some var www app folder that would be ultimately in the container once it runs. But this is just how we're going to build the image. I'm going to set that folder as my working directory. That's going to be the root for my app. Okay, and then I'm going to run a .NET restore. I'm going to run a .NET build, I'm going to expose a port, and I'm then going to run the app. Now this is a development version. You might not run the app, you might just do these steps up here to actually build your code. Now substitute your backend framework, whether it's Java or .NET or Node.js or whatever. Now some of those don't have build processes per se, in other words there's no compile like with Node, but it does have an npm install. Right? So you could use one of these containers to install your dependencies, get all the code ready, then put that into the runtime production version of the container. So you can have a build container and then a runtime container. They call those multi-stage build Docker files, by the way. Now, what you do then is once you have this ready to go, and in the app I'm going to have for you, and I have a bunch of others as well up on GitHub, we'll have, this is a real simple example here. But then you're going to build your image. So what you're going to do is say, hey, Docker, I want to build this image. Now, my Docker Hub account is Dan Wahlin. So normally what you'll put is this will be your Hub account, wherever your Hub is. This is going to be the name I'm going to apply to the image. And then this is that tag I was telling you about. Okay, this is actually super cool because now I can tag 1.0, 1.1, 1.2, and I can very easily switch between those or even run them at the same time, just for fun because we could. I don't know why you would do that, but you could. Maybe you have an old app that you have to run it still because people still hit it, but then you now want to roll out this new app on the same exact virtual machine. Not a problem. You could do that. The dot here means where is the Docker file. That means I'm running this command exactly in the root of where that Docker file is. Here. Now that would build an image locally. So now if I did Docker images, you would see that image on my machine. It's not up in Docker Hub yet. You'd have to push that up to the Docker Hub or to Azure or whatever. So anyway, I'm going to go through this real quick. This just breaks down what I just said. All right, now locally I could run the container. Now this is my .NET container, but again, it doesn't matter. It could be PHP. It doesn't really matter what the container is. So you say Docker run, detach mode, which kind of makes it so my console comes back. External port 5000, internal port, remember it was 5000. That's what's inside of the container. And let's go back, and then there's the image name and the tag that I want to run. And that's how I would now that's like newing up the class. That's newing up the image and making the running container. Okay, now, here's the challenge with this. In the app, the little demo I'm going to wrap up with here in a little bit, we have all this kind of stuff you're seeing, or most of it. We have Nginx, and I have ASP.NET Core and Node.js as microservices. I have PostgreSQL and MongoDB as databases for those microservices. What else is there? I think there's one more. I can't remember. I don't think this app has Redis, but if it did, you could add that as a container. So the problem is we just saw all those Docker run commands. All right, well, even on this little simple app that's not real life, but at least it is showing a bunch of containers working together, kind of orchestrating them, I would have to run all those Docker run commands, and that gets really painful. So what we can use, at least locally, is something called Docker Compose. So I'll give you a real life example. There's a company in Scottsdale. They're building some, I don't know, multi-level marketing thing. Apparently I'm in the wrong business because I heard that company is doing just phenomenally well. So maybe I should have done multi-level marketing. But anyway, I am hearing the numbers going, holy cow, what am I doing? But it seems boring. So they have 20, last I talked to them, which was actually a couple months ago, they have 23 microservices. 23. Okay, and that's not even that much in some scenarios. Well, to bring up 23 of those would be very painful. You'd end up writing like a batch file, right? Because you'd have Docker run, Docker run, Docker run 23 times. Can you imagine? No. So luckily Docker ships with something called Docker Compose. I suspect some of you have used this if you've done some Docker. Some of you have. And this is a YAML file where you configure all your services. This would be, it'll configure your Angular app, your Node, your Core, your Java, whatever it is. You would configure all those images in this thing called a Docker Compose YAML file. Okay, then with 2 commands, I could bring up 23, I could bring up 100. I don't know if my laptop would support 100, servers, but if it could, I literally could bring up 100 of those with just 2 basic commands. First off, I need to build all the Docker files. Nobody likes to do that build process manually that I just showed earlier, Docker build, -t, blah, 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 blah. So instead, you can automate that with Docker Compose build. And what that will do is take all those Docker files and make images for those. All right, so just one command, and I could build my entire infrastructure. Now, if you have a lot of containers or images you're building, it depends on what you're doing. I mean, that might take a while because, if you're doing npm installs, for instance, on multiple Angular apps, well, that takes a little bit of time to go get all that. But it's a very easy process, and I'll show you that in just a minute. Now, here's kind of what it looks like. I'm just going to write this out real fast. So in this little sample app I mentioned, I have Angular on Nginx, calling Node.js and calling ASP.NET Core, and then 2 databases for each of the microservices, or 1 for each. So I have at the top this YAML file. The only thing that's nasty about YAML files is the indentation kind of matters. So if you're already doing Python and stuff, you're good at this. But if you're not, it's like, yeah, okay, yeah. I wish they just would have done semicolons or something. But anyway, this ASP service, this would be my ASP.NET Core. Now notice it says the Docker file is called asp.dockerfile. You can name it whatever you want. Notice the context is local to wherever this Docker Compose file is. So now it knows where to go get it. It's in the same folder. Now Postgres, I'm not building a custom image. I'm actually using an image that's up in Docker Hub or in Azure or whatever. And this is an image that the Postgres group has already put out. And you can get Postgres up and running on your machine. Literally give me, 2 minutes. And I could have full-on Postgres configured with passwords and everything, because I already have that environment code for my passwords and stuff. But I'm not building a custom image here. Now, if you don't have this image locally on your machine, first time you run the next command I'm going to show you, which is Docker Compose up, then what it's going to do is go in and pull down that image. Whereas this top one, there is no image. It's got to build it. And so that will take a little bit of time to build. And then the Postgres image would pull down, and then you'd have these 2 images on your local machine. Okay. Now, to get this up and running then, you would do Docker Compose build, which I'm going to show you that here in just a moment. I'll show you this little mini app of Angular with all this fit together. And then Docker Compose up. Done. And now I could run my entire microservices architecture with those 2 commands, literally. Now, for production, if you only had a single VM, you literally could SH in to your VM, well, assuming it's Linux, or PowerShell N if it's Windows. And you could run these commands, pull down the images and build them on your like production machine and run it that way. But the problem with that, you're not going to get any monitoring. All right, that's where Kubernetes or Marathon or other options, Docker Swarm, that's where they come into play, is they help you manage all the containers, and there's a gazillion products out there now that'll actually give you charts and stuff like that. All right, and then you live long and prosper. That's pretty much how it works. So to wrap up here, let me kind of show you this little app. So I have this little app here. Hopefully that's loud enough. I'm pretty loud, my wife assures me, so I'm probably fine. All right, let me make this a little bigger for the back row. Yeah, I don't know. Is that theme better? You guys like, would it be better light? Or is that readable? What do you think? Good enough? Okay, moving on. I don't know, from here I'm going, it's pretty freaking dark, but
we like it.
You like it? Yeah, I know. It's like, what's up with the freaking lights? Like, turn off the lights, we're cave dwellers. All right, so let's go into this little app here. Now, you might recognize this. Pretty standard stuff, Angular CLI. Now, what I did, because this is just a GitHub repo that you can pull down, is I went ahead, and I'm not saying I recommend this for the architecture, but I went ahead and made my microservices that Angular calls and just put them in this microservices folder. Now, normally those would probably be completely separate from the Angular project, but I had to make it so you can pull it down easily from the repo. So you'll notice that I have an ASP.NET Core. Okay, and if I open this up, you'll see I make a .docker folder, and that's where I put my Docker files and stuff like that. And then I have a node. Okay, and then obviously at the root we have the Angular stuff, and there's even a Docker Compose. Now, what I want to show you first is, let me go to the top of this, and here's my Nginx. Well, there's my configuration. I won't go into that, but here's my Docker file. All right, now look how basic this is. Now this isn't for production, this would be for development, but notice from Nginx Alpine, let me move that, you always have to put who to blame, that's your author. And then notice I'm copying this Nginx config into a certain folder that's going to be in this image, which ultimately becomes the container. All right, then I expose my ports, port 80 and 443 for SSL, and then that's one way we can fire up Nginx. That's starting it. Done. Now, what's cool here is you'll notice I didn't copy in, though, any Angular code. Okay, this is kind of my development version of this. And the reason is if we go to the Docker Compose, let's go find the Nginx here. There we go, right there. And so I came up with a pretty creative name. I'm calling it Nginx. The image is based on Nginx, but because I have a build context, it's not going to use the image. It's actually going to use my Docker file. It's going to build a custom one and call it just Nginx. Now, this is the part I want to show you, though. When you do an ng build, what gets created? A dist folder. So what am I doing with this thing called a volume? Well, here's the first thing you'll hit if you're new to this when you work with containers. You will build an image, copy your code into it, and then run the container, and then go, oh shoot, I screwed up one of the lines of code though, so I got to rebuild the image now. And then, another 2 minutes later, you rebuild the image, and you see where I'm going. You don't want to debug that way. It'd be nasty. So what Docker allows you to do is imagine a container is like a bubble that's isolated. Okay, and it's kind of sitting on top of my Mac in this case, or your Windows machine. Now, what I want to do though is I want to poke a hole in that bubble and point it from a folder in the bubble to my local hard drive. Okay, and in this case, you'll notice I'm pointing this /dist, which is of course where my ng build is going to go. And inside of Nginx, this is their default folder for where you put static files. So what I'm saying is, hey, Nginx, anytime you go to run your server, point your normal location in the container, in the force field, in the bubble, however you want to look at it, to this dist folder, local. Now guess what happens now? Container comes up. I do a new build of my ng build, or I do it with a watch or something. And now I never have to stop the container. Now I'm running and developing now for real my Angular code inside of an Nginx. Now, do I do that just for fun? No, I don't. I use ng-serve as much as I can. But once I'm ready to move to that next stage of staging or production or whatever, then I'll start doing this and using a real server to make sure it works right. Then I'll make another Docker file that actually copies in the Angular code as part of it, bakes it into the image, and that's what I'll deploy to staging and production, that image. And that way I can develop locally against real servers, but then when I'm ready to go to production, I can do that. So, all right, so you'll see the ports on here and stuff. Now this is again the Docker Compose I'm gonna run in just a moment to wrap this up. Now just to show you, because I don't have time to go into all this, but we have a node microservice. Notice that the Docker file is in this microservices node, and you guys can look at this. I'll give you the link here in just a little bit for this. And then it also has a volume. So if I want to build my node code locally, but run it in a real server, I can do that. Same thing for ASP.NET Core. Well, Mongo's being used, by the way, for Node. I put a comment here because right now there's no password on it. That's bad. Here's my ASP.NET Core service for Docker Compose. Again, notice a Docker file. So pretty much every microservice has a Docker file. Typically more than one, because you'll probably have a development version, maybe a staging version, maybe a production version. It depends on how close your staging and production are when you do this. And then I'm using Postgres as that database, just because I like it. All right, this last thing I won't have time to go into, but this is a little free container inspector. So what happens if I get all this up and running on like a staging server? How do I know how much memory is being taken up, how much CPU? I want nice little charts. CAdvisor is a container that monitors containers. And so now I can hit a URL, I think port 88, yeah, 8080, and it would show me this admin page that would give me status of all my containers. I call this the poor man's container monitor. If you want to step it up a notch, that's where you go to Kubernetes and some of the bigger solutions. But for this simple one, this works. Okay, so how would I get all these going then? Because you'll see we have, 2, 4, 5, 6, counting CAdvisor. We have 6 containers, 6 images. How do I get this going? Well, I wanted to keep you guys till about 9 because you're going to watch me type Docker run like 6 times. No, we're not going to do that. So what I'm going to do is I have this Docker Compose file here. So we'll just go and I'm using VS Code here. And normally I would do this first. I'd say Docker Compose build. Now I've already done that because that will take on this one, depends on your machine, but I don't know, maybe 2 minutes, something like that, to build my images. Now I've already done that, so now when I'm ready to actually run this and run my Angular code, I'd say up, hit enter. Now I didn't do -D again, so it's going to lock up my console, but this is now showing me all the logs of all the servers, and I'm now running Nginx, Node, ASP.NET Core, Mongo, Postgres, CAdvisor on my laptop that easily. Now this one does package restores for Node and for ASP.NET Core, so it'll take a sec, so I'll come back to this in a moment. It also seeds the databases with fake data, so it takes just a sec to get up because of that. So while that's going, let me go ahead and wrap up here. So now when you're ready to really do this for real, this is where some of these kind of, we'll call them the big boy tools or big girl tools here. Kubernetes is my preference. They quite honestly seem to have won the battle so far of the mind share of developers, but I know of some people using Marathon and Docker Swarm. Docker now supports, I can run Kubernetes, full production example, right on this laptop now. It's now part of Docker Community Edition. And Kubernetes is, again, it's kind of like an orchestrator for all your containers, but more production. So I have some slides on that. I'm not going to go into those because they're kind of boring. But the app I'm about to hopefully run here, we're going to hope it runs because it's the last thing I'm going to show, is right here. Angular Docker microservices. Now, I will pull the one link you need if you missed it up again, so don't worry about this. But I have a bunch of other ones that use Angular, and some don't. But most of them have Angular in there of containers with Docker, and this is the one that's more kind of microservices oriented, though. All right, so that's where the content will be. But let's go ahead and let's check our logs here to wrap up. And all right, cool. So it looks like once I see this port 5000 listening, that usually means I'm good to go. So now, Nginx, what was that running on? What port? 80. I don't have a certificate on this one, so I won't hit 443, but I can run port 80. So now those images are local, right? And it just started up the container. So now I should have six containers running. And because it's on 80, I should just be able to go to localhost. All right, and there we go. So this is just a simple CRUD operation Angular app calling these microservices, all in containers though. And now I can come in and I can edit, and this one will update Postgres SQL. So if I hit update, it's updating the database. Pretty standard CRUD operations. You can delete, you can filter. Pretty normal Angular looking app. You can add new customers and so on and so forth. So for those that are new to this, if you want the app, I'll go back to the main link. But I hope everybody, first off, if you're new to microservices, to kind of wrap up here, I hope everybody gets a feel for some of the benefits, but also some of the things to watch out for. Again, I'm a big fan of microservices, but only when done right. When you have not planned, let me go to that link there for you. There we go. When you haven't planned your microservices very well, I think you're setting yourself up for a disaster. So make sure you know what you're getting into, especially when you start communicating between services and having transactional capability. There's some patterns out there like the Saga and others you need to know, because otherwise there's no ACID transactions like we're used to in a traditional database, because each microservice has its own database. Reporting, got to think about that too. What a lot of companies will do is when they do have microservices with different individual databases is they'll have an automated process that will do pulls from those into just a reporting database table or tables, and then they'll report off that. That adds complexity, right? If you're going to go containers, which I highly recommend, knock on wood, last comment here, I've been using containers for almost 3 years in production now on various apps, not only customers but ours, kind of dog fooding it. And literally, I have not had a single blip. Now, I'm not Amazon.com, I'll admit. We don't get nearly as much traffic, obviously. Okay, but while they're not perfect, they've been extremely stable for us. Now, I'm running the Linux ones. I haven't run the Windows containers. Anybody running Windows containers in production in here? Not really? Okay. So I'm guessing everybody that raised your hand, you're doing Linux. But I hope that gives you some, at least food for thought on, do we want to move to this kind of microservices or containers even approach? So as an Angular developer, I think it's a pretty exciting time. You really don't have to be an expert in Docker to be able to containerize your Angular apps. It's literally, in 10 minutes, I could show you a blog post or a gist, whatever you call them, where you could containerize your Angular app in like Nginx or Node or Apache with just very simple commands.